F net was equal to mass into acceleration in the linear motion, isn't it? But here force is being replaced by the torque, isn't it? So torque net will be equal to something into acceleration. For acceleration, we will use a term angular acceleration. That will be alpha. Alpha is known as angular acceleration. Hope you understand. This will be the angular acceleration. Is this okay? So torque net will be equal to angular acceleration, and in place of mass, there would be something which decide the rotational inertia, of the object. Because here was the mass decide the translational inertia of the object. So at this place there should be something which decides the rotational inertia of the object. So what is that quantity which decides the rotational inertia of the object? That is denoted by I, and that is known as moment of inertia. Is this all right? That is known as moment of inertia. So how to calculate moment of inertia of any object? Is this okay? We can go to the next page. Actually, this whiteboard is very, very good. Many of my colleague is using this whiteboard, and they recommended me today. Okay. I am not getting where is the option of going to the next page. Can anyone see it? Let me open my whiteboard. Yeah. So moment of inertia, torque net was equal to I into alpha. I was equal to moment of inertia, inertia of rotation. Is this okay? So moment of inertia is basically, it tells us how the masses as distributed, masses of object are distributed about the axis of rotation. Is this all right? About the axis of rotation. Is this okay? So mathematically, moment of inertia is equal to integral of dm r square. Is this okay? Integral of dm r square. So there are two type of object. there is a continuous object. So for continuous object, the value of moment of inertia is equal to integral dm r square. Is this all right? And for discrete mass system, suppose this is the axis of rotation. At x1 distance, there is a mass m1.
Sir,
At x2 distance, there is another mass which is kept and its name is m2. This topic is very, very easy, a student. So, and at this point, there is another mass m3 at x3 distance. So what will be the moment of inertia about this one? Moment of inertia will be equal to m1 x1 square plus m2 into
sir,
x2 square plus m3 into x3 square and so on. Is this okay? So that is the summation of m1 into x1 square plus m2 into x2 square plus m3 into x3 square. That is the moment of inertia for the discrete mass system. Is this okay? And for continuous mass system, what we do, like if you select a rod, for this rod at r distance, I will take a small thickness dm, dr, its mass will be equal to dm. So what will be the, suppose this is the axis of rotation, what will be the moment of inertia for this dm? Moment of inertia for this dm will be equal to dm into r square. And if you will integrate it, you will get the total moment of inertia of the rod. Is this all right? So this is for continuous object, and for discrete mass object, this is the moment of inertia. Hope you understand. Is this all right?
sir.
Yeah, tell me.
Sir, can you go up, sir? Sir, there you wrote moment of inertia, right, sir?
Okay. Copy.
Sir, can you read the last line, sir?
It tells us how the masses of the object are distributed about the axis of rotation.
Okay, sir.
So now, suppose I am giving you example. Suppose this is the origin. This is x-axis. This is y-axis. Origin. This is origin. So suppose this mass is 1 kg, which is kept at 2 meter distance, 2 comma 0. Another mass is kept at this one. This is 2 kg. So this is 0 comma 1. Another mass is of 4 kg. That is equal to minus 3 comma 0. So find moment of inertia of objects with respect to origin. What is the moment of inertia of object with respect to origin? Do it first.
Sir, can you go up?
Yeah.
Yes, sir. Thank you, sir.
So according to the formula, just we have to apply the formula. Moment of inertia will be equal to m into x square. So this 2 square plus 2 into this distance is 1. So 1 square plus 4 into this distance is 3. So 3 square. So this is equal to 4 plus 2 plus 9 4 ja 36. So that is equal to 42 kg meter square. That is the moment of inertia. This is very easy topic and very scoring. Most of the time they used to ask one question from this topic. This okay, so this is very interesting and a scoring topic. So now this is y-axis, this is the x-axis. This is the square. Here massage is 1 kg. Here the massage is 2 kg. Here also massage is 3 kg. And here is the mass that is equal to 4 kg. Isn't it? The side length of the square. This is a square. Side length is equal to 2 meter. This is origin. Find moment of inertia about origin. About origin. Do it fast. What is the moment of inertia about origin? Do it. So what will be the moment of inertia? So about this point, the moment of inertia of the 4 kg will be 0 because 4 into 0 square, because distance of 4 kg from this point is 0 and distance of 3 kg from this point is 2. So that is equal to 3 into 2 square plus this distance is 2 root 2. So moment of inertia of 2 kg is 2 into 2 root 2 square plus moment of inertia of 1 kg is 1 into 2 square. That is equal to 4, 12 plus this is 8 2 is 16 plus 4, that is equal to 32 kg per meter, kg meter square. Is this okay? This is the answer. Good. Now, do one more question, then we will start the continuous object. Okay. Suppose this is equilateral triangle. There is one mass, that is 1 kg. Another mass is at this point, that is 2 kg. Another mass is situated at this point, so this is also equal to 3 kg, let's say, and this length is equal to 2 meter, isn't it? And this is a equilateral triangle. Equilateral triangle. Find moment of inertia about origin. First one. Find moment of inertia about y-axis. Third one. Find moment of inertia about x-axis. Do it fast. Yes, so student, first of all, we will calculate about origin. So about origin, moment of inertia is equal to moment of inertia of 1 kg is 0. Moment of inertia of 3 kg is 3 into 2 square plus moment of inertia is of 2 kg is 2 into 2 square. So this will be equal to 12 plus this will be equal to 8, that is 20 kg meter square. Is this okay? Now moment of inertia about y-axis we have to calculate. So about this y-axis, what is the moment of inertia? So moment of inertia of 1 kg object will be 0 because it is passing through the y-axis, so its distance from the y-axis is 0. What is the moment? So moment of inertia of this 1 kg will be 0. This 2 kg object is at a distance of 1 meter from the y-axis, isn't it? So its moment of inertia is 2 into 1 square plus this 3 kg object is at a 2-meter distance from the y-axis, so its moment of inertia is 3 into 2 square. That will be equal to 2 plus 12, isn't it? That is equal to 14 kg meter square. Is this all right? Now, third one, moment of inertia about the x-axis. So moment of inertia due to 1 kg will be 0 because that is on the x-axis. So its perpendicular distance from the x-axis will be 0. Moment of inertia about of 3 kg about the x-axis will be 0, plus this distance is basically equal to, this is 2, this is 1, so this distance is root under 4 minus 1, that is root under 3, isn't it? So its moment or 2 kg moment of inertia about x-axis is m into r square root 3 square, isn't it? That is equal to 6 kg meter square. Is this all right? Now,
Sir, can you go up? Second one.
okay, okay.
Sir, the second sums.
This one,
Yes, sir. Thank you.
for continuous mass system, suppose there is a rod, this is the rod, this is hinged at this point, length of the rod is L, isn't it? So we need to find the total mass is M. We need to find the moment of inertia about this point. So at x distance, we will take a small thickness of dx, isn't it? So its mass is, what is the mass of this dx thickness? That is dm. Dm will be equal to mass per unit length into length of the thickness is dx, isn't it? So moment of inertia of continuous mass system is dm into x square. So integral, what is dm? Dm is m by l into dx into x square. You have to face this thing. You have to face integration. So you have to integrate it from 0 to L. So m by L will be outside of integration. So this is equal to x square dx, 0 to L. So that is equal to m by L into L square by 2. That is equal to L cube by 3. So that is ml square by 3. Is this okay? So you need to remember this one, this thing also. If this is a rod, moment of inertia about its one axis, about its one end will be equal to m into L square by 3. Is this okay? This is important formula you need to remember. Copy it and do the second part by yourself. What is this mass is m, length is L, and you need to find the moment of inertia about the midpoint. I about the midpoint. Try to calculate it. Is this okay? So if you will calculate it, again at x distance, you will take a small thickness dx. And again, you will get the same expression, that is integration, a moment of inertia is equal to m by L into integral x square dx. But this time limit has been changed. Limit of integration, this is x is equal to minus L by 2. And this is x is equal to plus L by 2. So limit goes from minus L by 2 to plus L by 2. Isn't it? So this is equal to m by L into x cube by 3, and integration goes from minus L by 2 to plus L by 2. So if you will calculate it, you are going to get m by 3L into, this is L cube by 8 minus plus L cube by 8. That is equal to m by 3L into L cube by 4. This is L square, so that is moment of inertia is equal to ml square by 12. Is this all right? This is ml square by 12.
Sir, sir.
Yeah, copy it. So you need to remember all these formulas. I will make the list of the formula also at the last. For center of mass, I had given a trick. For this one is very easy. That's why I does not use to give any trick. This will be remembered when you will practice a lot of questions by yourself. Now this is the ring, not question. This is the ring. This is the third one. This is ring. Mass is m, radius is r. What is the moment of inertia about this axis? So what you will do? So at r distance, you take a small thickness of mass dm. Because you can't take it as a x distance. You have to take the element at r distance itself. Isn't it? Because this is a circular. So all the masses are present at a fixed distance, that is r distance. So at r distance, you are taking dm thickness. So its moment of inertia is integral dm r square. So since r square is constant, so this is out of integration. So it is integral of dm. Integral of dm is mass itself. So this is equal to mr square. So moment of inertia of ring about the central axis is equal to mr square. Copy it. Now the fourth part is disk. Radius is r. This is the disk. Its mass is also m. So basically, if you can see, disk is a mixture of many rings, isn't it? If you start keeping the rings closer to each other, after some times, it will form a disk. Is this okay? After some times, it will form a disk. Hope you understand. Is this all right? So, at x distance, take a small ring. Take a small ring at x distance. Its thickness is, let's say, dx. Its thickness is, let's say, dx. So this is the small ring of dx thickness. So What is the moment of inertia of this ring, this small ring? So first of all, what is mass? Mass is dm. Dm is equal to m divided by pi r square, mass per unit area, into area of that ring. Area of that ring will be equal to 2 pi x dx, isn't it? 2 pi x dx. So is this one will be cancelled out. So this is the dm value. So moment of inertia is integral dm x square, isn't it? Integral dm x square. So that is equal to integral. What is dm? Dm is m by r square into 2x dx and into x square. So it will become equal to x cube. And that you have to go integrate it from 0 to capital R. So it will be equal to twice m by r square x cube dx 0 to r, isn't it? So that will be equal to twice m by r square into x to the power 4 divided by 4. That goes from 0 to capital R. So that is equal to m by 2r square into r to the power 4 minus 0. This will cancel this one and this will become equal to r square. So moment of inertia of disk about the central axis will be equal to mr square by 2. Is this all right? This will be equal to mr square by 2. Hope you understand. This is also a very, very important formula. Copy it. And you have to practice this derivation at your home, isn't it? You have to practice it. Is this all right? Now the moment of inertia of first one hollow sphere and second one that is solid sphere. Hollow sphere is this one. Its radius is r, mass is m. Solid sphere is this one. It is having also radius r, mass is m. So hollow sphere moment of inertia I will be equal to about any axis passing through the center. Moment of inertia will be equal to 2 by 3 mr square. Is this okay? And its moment of inertia will be equal to 2 by 5 mr square. Is this all right? Copy it. Have to remember formula. No. Hollow cylinder. So if you see the hollow cylinder, it is like this, isn't it? So if you mass is m and radius is r, and this is the axis about which you are calculating the moment of inertia, then if you look it from the top, then what you can observe, this looks like a ring, isn't it? Means mass distribution in a hollow cylinder is just like the mass distribution of ring, isn't it? From the axis of rotation. So its moment of inertia is also equal to mr square. Is this all right? Now, solid cylinder. This is a solid cylinder. So its radius is also r and its mass is also m. And if you find the moment of inertia about this axis, if you look it from the top, what you can notice? You can see that this will look like a disk, isn't it? So can I say that mass distribution in a solid cylinder is just like the mass distribution of the disk, isn't it? It's just like the mass distribution of the disk. So I will be equal to moment of inertia will be equal to mr square by 2. That is equal to that of the disk. Is this okay? Copy it. Is this all right? Do some questions. This is a plus symbol. Its mass is m and whole length is L. Its mass is also m and length is L. This is the intersection point. Find moment of inertia about point of intersection and perpendicular to the plane of the rod. Read fast. So there are two rods. I can compare it with the rod, isn't it? This is an individual rod. This is another rod. So moment of inertia of one rod with about a point passing through the midpoint is equal to ml square by 12. So there are two rods. Its moment of inertia is also ml square by 12. This is a scalar quantity, so you can directly add them. Add them. So that will be equal to ml square by 6. That is the answer. Is this all right? So now, have you heard the name of Ashok Chakra? Ashok Chakra.
Yes, sir.
If you don't
Yes,
know,
yes.
Modi ji will throw you out from the country. So Ashok Chakra is our national symbol, isn't it? National symbol. This is just like this shape. And it has some spokes. Do you know how many numbers of spokes in Ashok Chakra?
24.
24.
24 basically. 24 spokes is there, isn't it? Each spoke, actually 20 spoke, 24 spokes tells that in one day there is 24 hours. Is this okay? That is called like that. So this is 24 spokes. I am not drawing 24, but you have to assume this is 24. Each spoke has mass equal to m. Radius of Ashok Chakra is capital R, and mass of ring, there is a ring in Ashok Chakra also, that is equal to 3m. Find moment of inertia of Ashok Chakra about the center. Is this okay? Do it fast. This is a good question. Do it. So moment of inertia of each spoke. A spoke is just like a rod, isn't it? That is just like a rod which is hinged at a corner, at one of its end, isn't it? So its moment of inertia will be equal to, what is the formula? ml square by 3. The first formula, isn't it? So here the moment of inertia, and there are 24 such spokes, so multiply it with 24. Now plus, what is the moment of inertia of a ring? That is equal to m into r square. Mass is 3m, Radius is r, so m 3m into r square. So it will be equal to 8 mr square plus 3 mr square. That is equal to 11 mr square. So we can calculate the moment of inertia of even Ashok Chakra as a symbol of our country also. Is this okay? So today up to this, revise it well. In the next lecture, we will study two important theorem that is known as a parallel axis theorem and perpendicular axis theorem. That we will study in the next lecture. Okay. Hope you understand. Thank you. Bye.